We're here to talk through this Killer Sudoku by Serkan. One thing it does particularly nice is a little bit of a change of the usual formula. The usual formula in a killer is take small cages with extreme values. A good example is probably like this 6 cage or the 7 cage. 7 cage is 1 plus 2 plus 4, no other options. 6 cage is 1 and 2 and 3. And these extreme values let you at least place pairs in the grid which give elimination. So in this case, the only digit that can be used up here is a 3. The 1, 2 is there. The small digits have been used in these columns, and so you can make headway just through that. And if we looked on the other side of the grid, for instance, this 22 cage has to have a 9 somewhere in it. A 22 is 9 plus 8 plus 5, or 9 plus 7 plus 6. And so that there is a 9 somewhere here is a step we could use in our solve, but the way this is different is this puzzle has a lot more, in this case, 2 5-cell cages, 2 6-cell cages, and a 7-cell cage. The puzzle has its key break-in moments, both at the start and towards the end, being looking at the remainder, sort of what is not in these larger cages, which is less common to see in killers. Not absent entirely, but just less common. The best place to start actually for the whole puzzle is around this 41. Remember the digits 1 through 9 sum up to a total of 45, so the amount that's missing from this cage sums up to 4. 1 plus 3 is the only combination that sums to 4, so this is effectively all digits but 1 and 3, which means that in the other cells in this middle column, 1 and 3 have to appear. 1 can't be in this cage, so it's got to be up here. 1 was 7. The 3 then is going to fill out this bottom with an 8. The larger digits in these pairs have to be present in this larger cage, and so we don't know if the 7's on the left or on the right, but 7 and 8 form this kind of pair. And what is the way this puzzle nicely unlocks after you see this pair is we start to get information. For instance, the 15 now has to be 9 with 6. Talked about how a 9 has to be in the first column in these cells, so this cage is actually 9 with 6 like this. We can then use that and come to the bottom here. We can look across. Let's look across first. This cage here now has to have 2 digits that sum to 9. Everything that's very large has been used, so the only remaining combination is 5 with 4. Remember, 4 is already used in this column. So this is 4, 5 with the 4 on the left, because it can't be on the right. The remaining digits here are 1 and 2 and 3. This column can't have a 1 and 3, so this is 2. And we get 1, 3, 1, 3. This is sort of the intended initial break-in. The other thing I mentioned was starting to look in this corner. At the very start of the puzzle, there were a lot of options for this 21. That's because 21 can be a few combinations with 9. And there is exactly one combination that doesn't use 9, which is 6 plus 7 plus 8. What we'll see is the 9s have already been excluded from this cell. So the largest digit can be 8. 8 with 7 and 6 gets us to here. The 6 being in this cell means that this combination 985 is what's used up here. So with 985 here, with 8 and 6 used here, the only digit that's possible in this is 7, and the 8, 6 remain over in these cells. Looks like we've used 8 in both of the bottom rows now, so an 8 is going to be up here. I'm seeing if there's other progress we can do. This being 4, 9, impossible with 4 here, 5, 8 being impossible with this. This has to be 7 with 6. Not too helpful, but we can mark it in the grid. Well, actually it is somewhat helpful. With this being a 6, we get the 6, 8. That pushes this 8, 3. Into the grid. What we really should do now is look at some of these very large groups we haven't looked at yet. Let's start from the 33. 33 in 5 cells may be familiar to you, particularly it comes up a lot in cockroach puzzles. It has 2 options, 98763 and 98764. The key part is that this 987 is shared in all those situations. And as we look at the grid as we see it right now, the 7 and 8 can't be in these 3 cells, but they do have to be in this total sum. So this cell and this cell have to be a 7 and 8. Notice that this cell here can't be an 8. It's already been used, so the 7 is here, the 8 is here. We'll figure out the rest of these, but we do know at least that a 9 goes in this cell. I'm just going to follow up what I know based on placing this 7, which is I can finish out these groups. We said that 6, 3, and 5, 4 were the options. 6 is already in here, so the remaining digits in this cage will be 5, 4. That means this 3 is up top. This is 1, 2, 1, 2. 1, 2, 1, 2. This bottom corner has just the 4 left for it, and these other cells in this region are the 1, 2 pair. And the thing that will help us with the solve is that then now actually this middle set is 5 with 9 to complete this row. And there are some limitations on the adjacent regions, which will come to play now. So we talked about the 5-cell groups. What's critical right now is actually to go to the 6-cell groups, and these are situations you might not commonly consider, but they actually are absolutely vital to solving this puzzle. I guess we can do either. The 35 may be more obvious. 35 is missing 3 digits that sum to 10. And that means that the largest digit it can be missing is a 7. 7 with 1 and 2 could be 10. If it were 8 with 1 and 2, that would be 11. That's too many missing from the sum. So 9 and 8 are both required digits in this cage. If we actually look, 1, 2, 3, 4, 5, 5 cells can't have an 8. This cell must have an 8. We still have to think about exactly where the 9 can go, but it's not in these cells. A 9 has to be in one of these cells. And there's still a lot of options for what else is missing. It could be 7 with 1, 2. It could be 6 with 1, 3. It could be 5 with 2, 3. It could be other combinations as well. So let me just mark a few more things we know from the remaining digits here. And let's shift our focus to this harder group to normally think about. It has 3 digits that sum up to 12. Lots of ways that happens, but right now I've actually filled in 8 in each of these columns. And so what I know absolutely is an 8 isn't in this group, which tells me that the other digits that are missing are 1 and 3, because again, that's the only pair that adds up to 4, and 4 would complete the sum. 8, 1, 3 is 12. That means in these, every other cell around this cage, for instance, these cells, 1, 3, and 8 have to appear somewhere. They're not going to be in the cells within the 33. And what may be the hardest step to make in the puzzle, but it comes from digits we placed in the grid, thinking about where a 1 goes in this upper left corner. It's not in these first cells because we already identified what those are. It's not in these top 2 because that's used here. And it's not in this cell because that's part of a 33 cage where it's missing to make the exact number of missing sum correct. And so placing that 1 gives us a whole lot of progress. Sort of clearing out the chute, it gives us this 1 here as well. We have to place another 1 in this box. It can't be up top for the same reason as before. It's not part of the 33. We have to place a 1 in these cells. It's not here because it's not part of the 33. That's over there. Gives us a 1 down here. Gives us a 1, 2. 2 is going to fill over to here, like so. We can't do a lot more right now with the rest of the 1s, it looks like. But we've made some progress here which will help us around the middle. The 2, 4 is a helpful thing to have placed. Remember we mentioned at the start that the 7 was somewhat limiting. A 7, 1, 2 would be required. Once a 2 is in this grid, 7 can't be missing from the 35, so a 7 has to be here. We now actually have most of the digits placed, 4, 2, 8, 9, 7, all come into the grid. That adds up to 30, so the remaining digit is 5, and what's missing is 6, 1, and 3. The 5 only has this option. And place that. The 3 is going to come to one of these cells. The only place for a 3 then left in the 6th row is right here. The 9 is somewhere like so. The remaining 6 has to come here, which puts the 9 there. This is a 4. In this column 5, looks like that. This 5 forces the bottom cells we've already marked. We're going to need to get a 9 into this 33 cage. It's not in these cells because of the 9s nearby, so it's right here. The other digits for this are 2 and 4. Those can both go in the grid. The other digits here are 3, 8, 6. Those still look like they have flexibility, so we have to look elsewhere. The 2 that comes up here is one of these cells, so it's going to go over there. The remaining digit in this column we haven't placed as a 4. That means 7 and 5 are the digits that fit here. This is an 8 and 6 to finish that column. You have 9, 7, 9, 7. One thing we can start to do now, we've never thought about this 20, and 20 is a pretty tame kind of box. It has an average value of 4, kind of near the middle. Probably a 5-cell 25 is the least information box, but it's in a region that has this 1, 2, 3 constraint nearby. That means that actually at this point in time, the smallest value the 3 cells that are in the upper right corner can have is 18. Obviously we have some information from the adjacent digits which says it's, 15. We have some information from the adjacent digits which tells us that's not exactly right, but sort of view like 15 is kind of the sum here. This 2, 3 suggests that then the minimum value here, if this were exactly 15, would be another 2 or 3. If this were 16, 3 with 1, 17, 2 with 1. What we actually have is an issue where most of the digits are eliminated. The smallest is a 3, which would then force this. The smallest sum we can get into these cells is 5, and so this is exactly 15 in the 3 cells there. So what the 20 actually is, and we could have seen this in a different way after we placed the 1s, is the smallest you can have in a 25-cell group once there are no 1s in it, which is 2 plus 3 plus 4 plus 5 plus 6. And if you identify that these 5 cells contain 2, 3, 4, 5, 6, you're able to see this 4, 4, 5, like this is the way it fills out. So different ways to approach spotting that result, but what was great in this puzzle is each of these large cages you have to really think about the full sums before you can place too many digits in them. And that's somewhat unusual. So finishing out what we know in these spaces gets us this. This is the last spot for a 6. We still haven't placed this top cage of 7, but looking at the digits around it, the only sums that remain are 3 with 4. That's this, the 4. It's going to come to this spot. We have 5 with 9 remaining. The only place for 5 down here is there. So this will finish out a lot of these cells. We'll actually close out this. We could have finished this sooner after we placed the 6. We have to still complete this group. This is 9, 8. So what's remaining here is 2 of 7. The 7's already in this group. So the 7 has to be outside the cage here. Like this. The 7 moves this 7, 1. This 1 moves this 1, 2. These 2 come over to do this. The 7 is 7, 9. That 8 gives us 8 with 9. The 9 comes down, and the last digit's a 4. And we finished this challenging Killer Sudoku puzzle. It had a few different stalling points, but they all had this commonality of what was missing from a large group was critical at the very start. That set up this 1, 3 logic, which gives us that full row. Later in the puzzle, it's about identifying what's missing in this cage, and this cage, and this cage, and ultimately finding that this 20 is the smallest it can be without a 1, which is 2, 3, 4, 5, 6. So it had a lot of good arithmetic and a fair amount of Sudoku skills, just standard steps to get around the grid. So it surprisingly takes a lot to solve, but it shows the quality of a handcrafted puzzle. So we hope you learned a little bit about solving Killer Sudoku. We'll apply with some of the other arithmetic puzzles like Cockrow that we host as well. And we'll see you again soon.